Okay, this video is for Withme sample. The samples is going to be analyzed is basically an IRC block, just like IAU, ZZY, or QQT. But this time we are not going to heavily doing the code analysis. Um, of course, we need to do the behavioral analysis to get the basic understanding of the functionality of the malware. The malware do have a special capability, try to bypass all kind of way for analyzing it, such as the Wireshark, and one of the API function is called the is debugger pleasant. That means if the malware find that um, you are, as the analyst, to put the sample inside a debugger, the is debugger pleasant will find out and try to terminate it. Same as Wireshark. If you Wireshark was turned on to analyzing the network activity of running of the malware will not run. It will terminate itself. So we follow the instruction that I given to you, try to find out the enter debugging function and then do a patch and then try to run it. That is the only thing I want you to do. So we are heavily using the IDAPO as a disassembler, try to find the enter debugging function and then do a patch. Beware, actually this malware do have some other features to have enter debugging, not only Wireshark or is this big debugger present. So see how depth you can do the patching to mitigate all the defense of the malware. Now let us go to the technical analysis. So same as the IAU ZZY, I drag out the sample from the library, infected. Of course, we can do something just like the file analyzer. Maybe the PE file may be able to allow us to have some more information. First of all, you can pay attention to the MD5 hash and then go to the MZ header 5A40, that is MZ. P header 4550, that is PE. Pay attention to the timestamp. The timestamp is 2013. And then P section, you see one section is text section. That suppose most important is whether they can showing the characteristic that is runnable, executable. And then P import, you need to wait some time. The import address table to be written. You see the registry update. And then, of course, I think you can find the create process, create file, copy file. Seems a dropper function is included. I'll let you find the other features. Export, nothing right here. And then, of course, you can go to disassembler. You can see the first entry point um, to find the push EBP and then move the ESP to EBP and then make a subtract, create a buffer. Now we put it inside the PE Studio and you pay attention to the red thing import, you see some suspicious import. One thing you need to be aware, make sure your adapter to connect to internet has been disabled. And then we go to the section table, then you will find that that is executable, that is characteristic field. We check in the section table in the section 0. and it also properly named it as dog test. And pay attention here, you will see some more section here. You find BSS, some suspicious that is a BSS section, but the byte is zero, so it shows the uh, color in red. In string usually show you something just like IA uses it, right? You can find the command here, but I can tell you, you cannot find the um, any command just like QQT command that I show you previously. You will see yeah, the browser agent. You will see the some other things as the 172.2.0.1. And then when you're moving down, you can see some other things. mibbit.com IRC client. It's the hashtag is also like RZ is also IRC client. Maybe it's good to turn on the IRC server to when we perform the behavioral analysis. That is not included in my guidelines or question. And here, sandbox is in some kind of sandbox machine that you a sandbox environment that you can run on a VM, and when you run the VM, the sandbox will try to control the malware and try to do the behavioral analysis automatically for you. VBox, which is a virtual box, which is disabled in this sample, while John box server and John box server, just like the sandbox that can do the automatic behavioral analysis for you, or which these words may show that there's entered debugging function, including these other things that I have not mentioned in the questions. So when we drag down more, you can see whatever. Okay, you don't find the URL name, I mean the domain name here, but later on when we run the sample, you will be able to see some other interesting thing. This time we are not using Process Hacker, but instead we're using Process Explorer. Same function as Process Hacker, but one thing is it may provide the string information when the binary running in the memory. Sometimes the binary may, even though it doesn't look like it is padded, but some of the data have been encrypted, and this encrypted data will not be disabled. We will not be able to see in the string unless it is running. Okay, I put this in the corner, just like the process um, hacker. I try to minimize the other things and then try to make this window smaller. Now we can kickstart everything. So first thing I have to do is kickstart the, I intend to put Wireshark in the first time. And this Wireshark version, we do not have the loopback adapter, so we just capture anything. My objective is not trying to capture the packet because I want to make sure the anti-debug function is functioning, working good. So I turn on the auto run. I stop the recording because it spent some time. Okay, I start the recording again, and because it is finished, and I save a copy as normal behavioral analysis process. I put everything inside the temp folder. Then I can close the auto run. Now I turn on the FigNet, pay attention to the FigNet, see whether it will generate any domain name when it try to resolve to connect to the IRC server. Also turn on narrowband. Is that I don't need to see anything right here. Now maybe this is the good time for me to kickstart the with me. Pay attention to the Process Explorer window. See whether we can find with me process start up. I double click it. I see nothing. Strange. So let me um, go back to the narrow band. I stop it. Later on, we analyze the process monitor log, and I don't see anything in the generated meaning. I don't see any meaningful things generated in the fignet. So I close down the fignet. I don't want to see it right now because I turn on the Wireshark. Let me close the Wireshark this time. I capture nothing. So this is the log of the narrowband, which suppose showing the content of narrowband is working right now. I don't see the pauses in the with me, so I don't need to kill it. So I go to narrowband data and try to open the process monitor log. Just click OK. Is hiding in the taskbar. So expanding it a little bit, try to find the four major activity of the Windows OS. First of all, I check the process tree. Process tree, when I click here, I find with me box try to start itself, but there's nothing right there. I don't see it in the um, process Explorer. So now I do a sorting to find the process Explorer with the with me function and go to event, include base, inclusive tree, just go to event. The process ID is 7692. You see 7692. It tried to start and create a thread, and then I don't see anything there. So how about I do a sorting to see the with me sample. I go to filter, go to the image path, try to find with me. Suppose I can find it with me. I add it as a filtering so that I can see in the process monitor what happened to the with me. So with me do have some activity right here. You see, we try to load some modify registry key or modify or check the registry key. And then you see it start the row 64, which is 32-bit environment process container when it was running in 64-bit environment. So you will see some more activity, image load, code file, create file. Doesn't mean that it's creating this DLL, it's reading this DLL. And the set registry key, file execution option, and then some other reading the stuff. And then the process exit, therefore I don't see anything right here. So it must be the anti-debugging function is making it ineffective. Now let me do some other thing. Let me clean up the some of the narrowband data that I don't need to use, and then I keep the Process Explorer on, and then I let me close this one. I don't think anything Auto One has modified by the malware because it's after the loading the image, loading the DLL, and we terminate. It must be early beginning of process of the um, binary. When it run, it will check everything first. If everything is not okay, it just terminate. It do nothing. So you don't see any modification of the auto runs. So this time I don't start the Wireshark. I keep kickstart the fignet, and then I kickstart the narrowband. Okay, I minimize it. Then what I have to do is I try to run it. So I run it this time. I don't have the um, shot on. Suppose I should be okay. Okay, with me coming out and it's trying to resolve a domain name called sex with me info. And now it's okay for me to collect the basic information of behavioral analysis, but I don't know what kind of the pod is trying to resolve. So as I said, it is maybe the IRC thing. Let me try to turn on IRC server, and later on I will try to turn on the extract so that you can see some activity responding right here. So I will kick. I will try to stop to save your time. Okay, I'm going to install extract from the tool supporting tool location. I install this extract. Uh, Now I need to create uh, one of the server using localhost. So I close. Let me connect it. See, I connect to my IRC server. You don't need to do this step. I just want to show you additional thing. Uh, See if I can get a reply. Yeah, yeah, suppose it will close. I don't know why this good alert's coming out. So I see if I can find anything. Yeah, I found a channel right here. The channel is inside. I need to join this channel so that I can see the malware, just like QQT. Don't try to find the command because I cannot find the command. I let you do. If you want to do it, you can do it by your own self. But at this moment, you will be able to find the process. Which process is trying to connect to the um, internet, trying to connect the ILC server. Now, you can use these Process Explorer, select a column, find the process network, receive, and sends. And you may be able to find, oh, there are two processes. The first process trying to connect the IRC server using the network activity, yeah, network receive and send. If I double click this, I open it, you can see TCP connection, IRC connect 667. So, seems everything that I make assumption is okay. Now let me check one more thing. I try to right click, go to property and go to strings right here. The image, means the PE file, something may be encoded or encrypted so that anything you see here is just the thing as if when you put it inside the bean text or when you put inside the file analyzer string or anything that can analyze the string of a PE file. So the same thing that we have been visit uh, the content previously before. Now let me click the memory. Memory is when the process is running, Process Explorer be able to find the strings content in the memory. Sometimes you may be able to find interesting thing. Let me scroll down. Yeah, the same thing. MIRC. Maybe I cannot be find it in previous section when I analyze the PE file. Now let me drag down a little bit, see whether I can find the with me, sex with me string here. Yeah, yeah, yeah. I want sex with me content. Yeah, you see here. Oh, no, no, not this one. Down, 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 down. You see a lot of the IRC command right here. So you can find setswithmeinfo.com just like you see in the FitNet, but you cannot find it in the PE file. Okay, so if you pay attention into this screen, maybe you can find some more interesting thing. Maybe you can put it inside your report. And, and actually, at the end of this video, if I do have time, I will show you how my skill set on doing the malware intelligence part, which is not part of the question. Now, let us stop everything and let me put the sample into the IDEPO to do the analysis. To save your time, I already shut down with me a process tree, and I run the auto run, and then I make a comparison, see whether it's still running. Okay. To save your time, let me put the IRC. Let me go to the narrowband. I shut down the narrowband and try to do some checking of the narrowband process monitor log. It's hiding in the below. Oh, it seems I already find my auto run has finished. Let me go do a comparison of my previous one. You see a couple of things coming out. That is a registry run key, just like the IAU SSY. Where's the location of the uh, file? See whether I can find the file. And this is also, again, this is also not a part of your assignment. So I go to the location and then try to find the user rank 2 application data roaming application data roaming. Suppose I should be able to find A171323010. Nothing right here. Bear in mind, I already turned on hidden item and file extension. Um, See whether I need to do some more thing. Maybe the file is under protection is hidden. Show hidden file. Can I show the system file? Show hidden folder extension for known file. I display everything, but I cannot find the file. I don't know why. So anyway, I let it to you to do the analysis. You can put this into your finding, but you can also explain everything right here. So auto run shows the auto start location, but we cannot find the file. I don't know why. Um, then we can go to the process tree. This time you will see more activity of the with me sample, and then you can do some more activity right here. You see the with me have a command point. What happened of this? I don't know. Maybe this is the reason caused by the uh, narrow band or some other activity. So now you see more activity running in the with me sample this time when I um, when I not using Wireshark. So for activity, I try to find the file summary, see whether I can find the folder activity of the auto start binary. So I go to the folder, user folder, find run2, and then application data, roaming, try to expand it. Yeah, I see something right here. The activity is right here, but I don't know if the size is right here. So it did write something right here. Maybe some setting prevent me to find this information. So this is one of the expected result that I'm going to do. So I let you yourself to find out the registry activity because it's already show you inside the um, auto run. So stack summary is not my major concern. Network activity, we already find it through the Process Explorer network activity, but we are supposed to be able to find a connect to 6667 and here. And then if we do a sorting, you will see this sorting at the background. You can find the TCP receive and send with me to the IR server. So behavioral analysis stop complete. Let me go to the code analysis. I do it quite fast this time because I don't want to destroy your um, entertainment when you're analyzing the sample. And I just do one patch. That is the Wireshark patch. So first time, the same thing. We are in the start. I try to do the call. It call to the 401020. So I click in, it seems have some major chunk right here. I can get a call. It call quite a lot of function inside. I don't know which one is important. Maybe this one may be interesting because it do this and then go to the process, exit the process. So here you see some more thing, still not the major one. How about we go to another tricks that I told you guys before? Try to do a sorting the length and then do and find the major part. The major part is right here. It seems so complicated. I can name it as what? Name it as main. So in the main, see whether I can do the cross reference graph too. Yeah, you see everything right here. Previously, I think I click the 4101C and then I go to 4060EB and then I come here. So how about I want to double check whether I'm correct or not, then I will, yeah, I want to keep these windows out, just minimize it, and you can always find it right here. Okay, so I go hit escape. I go to force 101C0. From the start, I move to here. Yeah, this should be okay. That is 401C. It will come down to the main location. Why his and then 404040EB may be interesting. 4040EB, I cannot find it here. Then maybe I can go to find 400 EB. But how about we go up, see what happened in the beginning. So I go to 40IA9F, which is the main. So how can I go up without go to that particular address? That is one another trick I want to show you. Hit space bar, you go to the content, and when you're moving up, you will see the code reference. It's code reference from these two subfunction. Okay, how about we click this one 4066E2E? Yeah, this is that one. Now I click this one and then I hit space bar again, go back to the program track. Wow, it's complicated. Okay. Then how about I go back to previous screen? I don't want to go here. Go to here, space bar, still, but maybe I can go to the top. I go to the top right here and then hit um, cross reference graph 2. I go upstairs, up one level already. Then I want to go up another one. Then hit space bar. hit spacebar again. Then I go to the top. Hmm. Oh, it's difficult for me to analyze. In that case, what should I do? Oh, don't forget, I already give you some hints because the wild shot is something that should be run at the very beginning. I want to find out the wild shot and is debugger Peasant's API call. So why not we go to search or go to view to do a searching in the string. So are there any search function right here? Yes, I do a search. I search a while, try to search the wild shark, wire shark, and then uh, I go to wild shark. If I double click it, I go to the code section. You see Wireshark, Sandboxy, VBox, Wireshark, Jumpbox. Okay, so if I click this, I go to the block that may use Wireshark. Here I got another new dimension, new location. You check the Wireshark. Then if I click here, go one step up by hitting the space bar and then go to the calling caller function. Yeah, I find this. This is interesting. Yeah, I find this 40XC47. XC47. XC47 is not in the original main. It must be below the main, I guess. So, uh, let me find codes. Any interesting thing? Oh, I can also find is the bugger present in this chunk of data. So if I want to bypass this, I need to find the location to do a patching. The simplest way to do a patching, suppose in this location, for example, if I just want to do the debugging, I just don't want it to go into this area, or I do the debugging for one of each one of them. For example, if I want to do the debugging of is debugger on, and I can remove the core this function. Or if I want to do the Wireshark, don't go into Wireshark. So if I kick back to by hitting the escape, I go back to previous screen, I hit the space bar, and I find it will call this location 408B11D. Then I click here for the upper caller function. The caller will call this. So if I do a patch 408C55, I keep record right here. Then I put it the notepad. Remember that um, address 40xc55 that I copied from the Wireshark. Then I put this inside the debugger. So I go to debugger, go to user code. Um, Bear in mind, is debugger present is functioning. You cannot do a complete debugging, but I can do a patching by using the debugger. I go to the address of 40xc55. Then I right click. Oh, sorry, I need to go to Control G. I need to 40 to change the go to address XC55, correct address. I find this call this function, just like the IDA poll, call 408B1D, 8B1D, call 08D, 8B1D. So I just clean it up. How to clean up? I don't want to cause. I don't want to do a call. So let me do a patching right here. Assembly. Now I don't want to do the call. I just don't want it to do anything. I try to type a function called NOP, do nothing. You will see something amended right here because the operand and instruction EB is the call and this is the operand. So I do a change. It changed, try to refill everything and then like that. So if that is the case, I clean up. Yeah, I don't want to do anything actually. So if this is the case, I just clean it up and let me do a save to do a patching. The patching this to 90 and then I patch the file and save the file called with me patched it with the function called Wireshark. So I let you do the remaining checking. Of course, you can turn on this as one of the function, one of the finding of the patch that the Wireshark. Uh, you can use the same thing to do patching the is debugger uh, presence API call. Um, but this time I don't want to uh, jeopardize your enjoyment when analyzing this um, sample. Uh, I only patch one for you in the video, so let me show you some of my analysis. So I'm thinking, always thinking. Here seems some kind of enter debugging function. If I name it called enter debugging function, called uh, anti-DBG. So let me see which function we call it. It's called by 440XDB4. Then I go one level up by hitting spacebar, double click, hitting spacebar again. You see somewhere, and the debugging is called right here. So, of course, I can do a patching right here, but it will miss some other things. But clearly, you will see after it call the enter debugging function, it do a testing of the AL, which is the EAX register lower byte. If they are testing, and then it will do a jump. If jump equal to 0, it will bypass. Otherwise, it will terminate. This is the reason why, and this is the part why the enter debugging when the first time when I run the behavioral analysis without with turn on the Wireshark and then I double click it, I cannot find the process create because it doesn't it detect it and then it terminate itself. So how to do a patching, this is one of the possible reason. If I want to do more study and I can go to the top of here and then hit space bar and then go one level up and then hit the space bar again. You will see here it call this. It pushing this information to the stack pointer just like making a call. Then it call create thread. Okay, that is another page. I don't want to see the create function of the anti-debugging things. If I don't have that thread running, I can bypass all the anti-debugging. But bear in mind one thing. Let me hit escape, go back to 40XCB4. Here, if something is important for execution of the binary, not only the anti-debugging function, then if you bypass this part, don't create the thread, the malware will not be executed properly. But it seems I already find the anti-debugging function. Of course, don't call it is another option. Do a branching here is another option. I let you try and then write your answer and do a screenshot in your report. Um, Final but not the least, I would like to draw your attention that I how I do the malware analysis intelligence study. Actually, this is an ILC block, and if you um, try to remember, that is one name in the memory called the Athena whatever ILC when I check the memory. You can try to do a Googling or my by AI try to run the try to do a search we call the ILC block or GitHub ILC block Athena. Maybe you can find some more information about Withme sample. Okay, that is the end of this video capture. I hope you like it, and I hope you passed a very wonderful Mid-Autumn Festival and try to make a submission of the first deadline on 12 October for Lab 1 and Lab 2. And this Lab 3 is due date is on, I think, 26th of October. I'll upload this to Moodle as well as the YouTube channel. Okay, bye.